Hello and welcome. Got a quick one for you today, I think. I promise I still have not forgotten about the challenge solution. It's coming very soon. But since tomorrow is a little sooner than expected, the first esports battle of the new year, I thought I would do a quick esports style question. This one is from the finals of the Microsoft Excel Collegiate Challenge, written by David Brown, who was one of the organizers of that super fun event. I was there for the final. Really interesting time, lots of interesting people. Anyway, this case is based on the game Snowman, which is based on another children's game on guessing letters. So the idea is you're given a word like this, a hidden word, and you guess letters that are in there. So maybe you say, I don't know, I think there's an E in there. You say, oh yeah, you got lucky. There's 3 E's in there. And then you say there's a D in there, and there's not a D in there. And basically every time you get a letter wrong, you draw, in this case, a piece of the Snowman. It was a slightly grimmer topic when I was a kid, but we'll leave that alone for now. And there are 10 different pieces. So let's see, you get one letter wrong, you draw this, and another letter wrong, you draw that. Third letter wrong, you draw that, and then fourth letter, I don't know, give him a hat. Fifth letter, give him arms. Sixth letter, seventh letter, eighth letter, ninth letter, 10th letter, something like that. Anyway, if you make 10 wrong guesses, all the pieces of the snowman get drawn, then you lose. And if you get the whole word before all the pieces of the snowman get drawn, you win. That's the idea of the game. I may or may not come back to the bonus questions at the end because I want to keep this one relatively short. But okay, so basically for each one you're given, this is the word that you're guessing at, and this is the order in which you guess. So you're given all 26 letters. So obviously if you get the word correct, then you won't get to the end of this. Well, actually, whether you get the word correct or not, like here, for example, there are only 7 letters in the word. So by 17 guesses, you have definitely either made 10 wrong guesses or made 7 right guesses. I guess you could say that by 16. But anyway, you get the idea. So the game does not last 26 turns, but there are 26 guesses there so that it doesn't give you information about when it runs out. So the first question is just on what turn is the first correct letter guessed. Second question is what letter is guessed on the first turn that's correct. Third one is what is the xth correct letter guessed. So for instance here, what's the third correct letter guessed in holiday? And the answer is Y, because I guess you get the A and then the D and then the Y. For this one, it's important to remember that, say here, for example, celebration has 2 E's. So if your E is your first guess, then E is both the first and the second correct letter. Then how many incorrect guesses have been made by the 10th turn? So in other words, of these 10, how many are not in there? And then level 5 is on what turn does the game end? So in other words, on what turn do you first either guess all the letters in the word or make 10 wrong guesses? So I'll try and do it in at least a semi-flexible way. So let's see. The first correct letter guessed. So we just want to find what's the first one of these that exists in here. So one way to do that is we could make an array, which is something like is number search this in here, and that'll, oops, 2 closing brackets, not 1. That'll give you true if it's in there, so P is in there, and false if it's not in there. Then I can expand this to give me that for the whole array, and it gives me this array of trues and falses, and then I can just match a true against that to find out where the first one is. So let me just grab that. Oops. And bring it over here. So I'm going to say X match true against that. And copy down. And those all check out. So then the second question is, what letter is guessed on the first letter that is correct? So here I'm just going to do basically the same idea, except instead of just matching to figure out where it is, I'm going to do a lookup to figure out what letter it is. So I'm going to XLOOKUP true in, sorry, let me just copy this down first. So I have the same formula, then we'll say XLOOKUP true in that range and returning from the range of letters. There we go, and that should all check out, and it does. So then the next question is, on what letter is the xth correct letter guessed? So now, for the first couple, I've taken the approach of kind of working with the array of letters. Do that here, do that here. You could do this question that way as well, but it's a little harder to account for the duplicate letters that way. So here, for example, for celebration, I mentioned there's double E's. Some of these have there's loads of K's in Melikimaka. So The easier way to work with it is actually by working with all the letters in here and seeing, just basically make an array. So first thing, you can just split out the letters by using mid this, then sequence len this. So what's that doing? The length of that gives you the number of letters in it, which in this case is, I guess, 7. And sequence of that gives you the numbers 1, 2, 3, 4, 5, 6, 7. So we're taking the first, second, third, fourth, fifth, sixth, seventh characters. So that's the character starting at that position, and you're just taking one character because that's the syntax for mid. And that'll give you sweater like that. And so then you can do something like X match that against this, and that'll give you the order in which they all hit. And then let me just copy this down to somewhere, this to celebration, say. You can see here, let's see, C-E-L-E. Yeah, so you can see that there's 2 7s here because there's 2 E's. So then I can sort this. Actually, I don't even need to sort it. I can just take, what do I want? Small? I want the third one. So yes, I want the third smallest number. So I'm going to take small of this. 3. I'm sorry, not 3. I want it to vary. And that's 5. I'm sorry, I guess I needed to. As you can tell, I've partially thought this out, but not really quite enough. So let matches. No, I'm using 2 names. LT MT. Sorry, I've got cap locks on. That's why it's doing cases funny. Letter matches be all this. Then I want to XLOOKUP small of letter matches this in letter matches and returning from here. Right from here? No, sorry. Sorry, I should have split this out. So I'm going to call this letters. Sorry. Returning from letters. I think that's right. Let's see. It gives me an A. So, sorry, I got a little confused as I was writing that and went back and changed things. And so let's just spell it out a little more clearly. So we're saying let letters be the sequence of letters in here, including all the repeats. So this is C-E-L-E-B-R-A, etc. Then letter matches is match that against these. So you find out where each one is found. And then you want to XLOOKUP the nth smallest value of that in the set of matches returning from the set of letters. And the one other thing I'm going to do is I'm going to wrap the X match. So if you look down here, you'll see that there are spaces. But obviously spaces are not guessed here. So if I copy this formula down here, it'll error out because of the spaces. So I'm just going to wrap this in an if error. And if that value is an error, then I'm just going to say 99, something that's bigger than any of the other values. And then I can just, oops, sorry. Then I can just fill that down. And those all check out. Okay, so then level 4, how many incorrect guesses have been made by the 10th turn? So I'm going to take what I took up here. And then I'm just going to modify that. So first, I'm just going to only make it go as far as the 10th. And then I'm going to say sum minus this, and that'll tell me, I'm searching, and search will return the number of the position it's in if it's in there, or an error if it's not. So is number tells me, if it gives me it is in there, I'm going to use is error to give me it is not in there. Then minus is going to turn those turn the trues into ones, falses into zeros, and we just copy that down. And then the last question is, on what turn does the game end? So basically what we need to do is figure out on what turn do you first have all the letters from here, and on what turn do you first make 10 errors. So I'm going to do that. I'll just call that W for win turn, and L for lose turn. So my win turn is going to be based on this one, because I can just, let me just copy this formula, put it down here, and don't worry about the errors. I just want to get as far as letter matches. Oh, and sorry, yeah. I only want to get as far as letter matches, so I don't need that, and I do need to move this back over here. So then copy that out. This is to figure out winning, and then I just want max of letter matches. So in other words, on what turn is my last match? So in this case, the last match is on turn 19. There's an L from lights there, and O, F, M, B, U, R, Z are all not in the word lights. So I win on turn 19 if I haven't already lost. And then the lose, I can use this logic here. So let's take this, and copy that, put it down here, expand it back out to 26. And now here I just want to have a cumulative count. So this is my, let me just put it somewhere else so it's not in the way. I'll put my array over here. That's my array of trues and falses according to whether or not those letters are in there. So P is not in there, so that's true, as in true, that is an error. So I'll put a minus minus on that. And then I'm going to use, I could kind of do this out longhand and do a running total on it, but I'm trying to, you know, do a mix of making this approachable but also teaching you some new things. So let's do a scan instead. Scan is basically a way to do running totals, simplistically. There's more to it than that, but start with that. So start with 0. This is my array, and the function that I want to apply to add things up is I take my accumulated so far and my new value, and I add them together. So this lambda is just the function that takes A and V and adds them together. And so that'll give me, so here I've got 1 miss, 2 misses, 3 misses, 4 misses, stays at 4 misses because T is in there, stays at 4 misses because S is in there, and so on across. And then I just need to X match 10 against this, and I want exact match or next larger item. And the reason for that is because you could have a case where your 10th and, sorry, no, never mind, I do not need an exact match. I was mixing up with the, with where you're matching the letters, where you could get 2 letters at the same time, but you can't get 2 misses on the same turn. So I do not need to worry about that. So that is the answer there. So that's the turn on which I lose and the turn on which I win. And then it's obviously just the lower of those two. So just say min. And that all checks out. Does the last one? Yes, that all checks out. All right, so I think this has been relatively zippy, so let's have a quick crack at the bonus questions. One thing I'll do before I attempt the bonus questions, I'm just going to squeeze up the format here so that the letters are all lined up. Get rid of my add-ons there. Okay, so what are the bonus questions? Across all the words guessed, which one has the largest number of different letters? Okay, so unique, let's, sorry, let me move that over here because I'm probably going to want to expand my win and loss to cover everything. I think that's one of the bonus questions as well. So unique letters, and I'm only interested in the games, not in the examples. So first thing is we can use my, where did I do the thing to split out? Here we are. We can use this little trick to split out the list of letters. So just bring it back up here. So mid of that, sequence len of that will give me all the letters in that, and then I can wrap that in a unique. And that'll give me the list of unique letters. So you see the extra O dropped out. The one thing you have to watch out for is there are spaces, and I think somewhere further down there might be like yes, there's an apostrophe and other odd things. So instead of doing that, I'm going to slightly change this. I'm going to X match this against the letters, and that'll give me everything I want there. But if I take that down to, say, here, you'll see it gives me an error for this space. So then I can wrap that in a unique. Let me see. Can we? No, that's. Yeah, what are we doing? Okay, so I'm going to say let letters, letter match be all that. Then I'm going to say unique of filter letter match, where is number letter match. And then I just want the number of rows in that, and that's my number of unique letters. If you didn't have the 26 letters just conveniently sitting here, you could also do it with code to figure out which ones are letters based on their ASCII code. But we don't need to do that here. So the question is, which one has the most unique letters? So obviously you could, whoops, sorry, I went to the end instead of the start. You could relatively easily go and like manually inspect, but we can also look up some large number. Well, I guess we can look up 27 because we know there'll never be more than 27 unique letters in here. Lock returning from, what's the question? It asks you enter the game number. Okay, so sorry, in that case we can just do X match. And we just need exact match or next smaller item. No, fail. Okay. Let's do the manual inspection then. Oh, sorry. Yeah, I can't do X match because there are gaps. So I need to do an XLOOKUP. Dumb. Lost points there, but anyway, that's fine. Return array is the game number. Boom, 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 boom. Lock. I don't actually need to lock because I'm not copying this formula anywhere, but that's fine. And I just need one more comma because there's another argument in between. That's also definitely not right. Sorry, that's because I'm looking at level, not game number. So punt that over. Third time's charm. Okay. Across all the words guessed, some letters appear more frequently than others. How many times does the most frequent letter appear? Okay. So there are smarter ways to do this, but let's go with a relatively friendly way. I'm just going to grab a list of all the 26 letters, and we'll figure out how many of each of those is in. And I've used this one a bunch of times before. The length of that minus the length of what you get when you substitute in this word all of this letter with blank. And then I need to lock the column of this because I'm going to copy it across. Actually, better than locking the column would be to do it as an array. And then copy that down. And then we're just going to figure out which of these there is the most of by doing some. Again, we could be more array formula-ish and squeeze it in, but trying to find the right balance of array formulas and sensible to a normal human formula. So we'll do somewhere in the middle. So I don't know, let's just look up 999, should be a safely large number. In here, returning from here, and we want the sorry, here we are, exact match or next small item. How many? Sorry, and the question is how many times does it appear? So I'm not going to return from the letters. I'm going to return from the counts. And finally, how many games does the player win? So here we just need to. So we have the win turn and the lose turn. So just need that less than that. They can never be equal because the turn number on which you lose, you have to have a miss. The turn number on which you win, you have to have a hit. So they can never be equal. So just add W question mark and Okay, and then we just have to count those. Count if on, I'll just be lazy and select the whole column, true. Ooh, I do remember the answer being different from that. A little disappointing. Presumably all these have to be right because what the heck is that? 999. Okay, that's not the right way to handle this. So in this case, I want my if error to be 0. So, ooh, that's not great. Okay, so yeah, and there we go. This one here was a win, but I got it wrong because of the space. So whoops on that. You got to think about why you want your if error to be behaving the way it's behaving. Anyway, yes, I remember thinking it was very odd that you would only get 6 out of 100 on this style of game, but I guess it's a function of how the data was developed, but that is the right answer. Anyway, that's all I got for today. I got to run. I'm going to be competing in the esports thing tomorrow, and back, I promise, with the challenge solution very soon. Thanks for watching. See you next time.